Introduction to the periodic table of elements. What is the periodic table? When you study chemistry, 100% of chance that teacher would ask you to remember the first 20 elements of the periodic table. But what is the periodic table? Is it just a normal table that shows all the elements in increasing number of protons? Not really. In fact, we can also see the number of occupied electron shells, the number of outermost shell electrons, and tell us how the elements react with others with a general idea. How can we do so? We can get started by having a look at what the periodic table is. There are 92 naturally occurring elements, while others are made in laboratories. In the past, at around 1899, only 63 elements have been found. It might be very confusing to handle so many elements all at once, so a Russian chemist named Dmitri Mendeleev arranged the 63 elements with their similar chemical properties in the same vertical column of a table, and named that table the periodic table of elements. That periodic table has been modified over the years to now, and now we have the modern periodic table. Elements are arranged in order of increasing atomic number, and as mentioned in the previous video, atomic number is equal to the number of protons of the element. For example, hydrogen has 1 proton, so its atomic number is 1. Helium has 2 protons, so its atomic number is 2. Therefore, the first element in the periodic table is hydrogen, while the second element in the periodic table is helium. Using this rule, the elements have been grouped effectively. However, if we just put the elements in increasing atomic mass, why do we need a table? We just list it out, right? Therefore, there are periods and groups in the periodic table. Periods are basically the horizontal rows, while groups are vertical columns. As mentioned before, Dmitri Mendeleev put elements with the similar chemical properties in the same vertical column. And yes, there are groups. There's a total of 8 main groups, and in fact, the group number is the number of electrons in the outermost shell. The period number is the number of occupied electron shells. For example, sodium has 11 number of protons. Its electronic configuration will be 2, 8, 1. Therefore, it has 3 occupied electron shells and 1 outermost shell electrons. Therefore, sodium is a period 3 element and group 1 element. There are some elements that are in between group 2 and group 3. They are called transition elements. Some people call them transition metals because all transition elements are metals. There are some names for some groups. For group 1, it is called alkaline metals. For group 2, it is called alkaline earth metals. For group 7, they are called halogens, and for group 0, they are noble gases. We will discuss them group by group later on. But first, let's have a look at the changes from metals to non-metals and the reactivities of the elements across a period. To the left of the periodic table, they are more metallic. To the right of the periodic table, they are more non-metallic. Noble gases are the least reactive. But if we consider group 1 to group 7, the more the element is close to the middle, the more unreactive it is. For example, silicon is not very unreactive. Therefore, it lies nearly in the middle of period 3. On the contrary, sodium are reactive metals. Therefore, they react more vigorously than the other elements in between sodium and silicon. What are groups? They are vertical columns of the periodic table as mentioned before. Let's first talk about group 1 elements. They are lithium, sodium, potassium, rubidium, cesium, and francium. As you all know, group 1 elements means that there are 1 outermost electron shells. Therefore, if we have a look at the electronic arrangement of lithium, sodium, potassium, etc., all of them have 1 outermost shell electrons. There are some similarities of group 1 elements. They are all are soft metals, all have low densities, all are reactive that they react with air readily, all react with water and gives off hydrogen gas to form alkaline solution, and finally, all react with non-metals to form ionic compounds. However, not all elements in a group must be having the same chemical properties. For lithium, it floats and produces hydrogen gas readily if it reacts with water. For sodium, it melts to form a silvery ball and moves about quickly on the water surface to produce hydrogen quickly. For potassium, it is more vigorous than sodium as that silvery ball will catch fire itself. For rubidium and cesium, they are even more vigorous. So, How can we predict whether something is more vigorous than the others? In fact, the reactivities of group 1 increases down the group. Now, let's have a look at group 2, the alkaline earth metals. There are multiple elements, namely beryllium, magnesium, calcium, strontium, barium, and radium. The similarities of them are that they have low densities, just like group 1 elements, but they generally are more denser than group 1 metals of the same period, or are less reactive than all alkaline metals, or react with water except beryllium, as they less vigorously than group 1 metals, or react with dilute hydrochloric acid to form hydrogen, or react with nonmetals to form ionic compounds. Similar to group 2 elements, the reactivity of group 2 elements increases down the group. For beryllium, it does not react with water or steam. For magnesium, it has almost no reaction with cold water, but reacts with steam in order to produce hydrogen. For calcium, it reacts steadily with cold water too. Now, we can look at the table that compares the reaction with water for beryllium, magnesium, and calcium. The reactivity increases down the group. Now, let's have a look at halogens. The first similarity is that they all have colors. For example, fluorine is a pale yellow gas, chlorine is a greenish yellow gas, bromine is a reddish brown liquid, iodine is a black solid, so as acetate. As we can see, the elements become darker in color down the group. Needless to say, all are very reactive. They will react with metals to form ionic compounds while reacting with non-metals to form covalent compounds. The reactivity doesn't increase down the group, it decreases down the group in group 7. The reaction with hydrogen will decrease down the group. Let's have a look at the table to compare. Finally, let's have a look at the noble gases. Noble gases are colorless at room conditions. They are all unreactive. In fact, if the outermost shell is full, then it will be considered a noble gas. For example, helium has 2 electrons in the only one occupied shell, and that shell is full. For neon, it has a configuration of 2-8. It has 8 electrons in the outermost shell, so it is full. Now you are familiar with the periodic table. Watch the next video through the end screen to see whether you understand by doing some practice.